Okay, we're just going to be working through some extra practice problems here on reading ABGs. These problems I have here are available on this website, survivenursing.com/ABG. This will generate 10 different ABG practice problems that you can do, and whenever you're ready, you can just click Show Answers, and you can check your results. So let's just go ahead and work through these 10 so you can get some more exposure to this. So, number one, we're going to draw our tic-tac-toe grid. So tic-tac-toe. This column is acid, this column is normal, and this is base. So we go ahead and we look at our first problem, 7.79. Our pH is 7.79. It is basic, it is alkalotic. So we write down our pH in the base column. We look at our CO2, it is 24. It is also a base, so we write down our CO2 in the base column. Our bicarb is 21. It is acidic, so we write down our bicarb in the acid column. So our tic-tac-toe was formed with these three parameters. So since it's in the base column, we know that we are in alkalosis of some sort. Now we need to look to see which parameter made up our tic-tac-toe. In this case it's CO2, and remember CO2 is a respiratory value. So we are in respiratory alkalosis. And then we need to see the opposite parameter. So in this case we use the respiratory parameter to make our diagnosis. So we look at the opposite parameter, in this case our metabolic parameter, and which column it's in. It's in the acid column. So this means we are partially compensated. So our system is primarily in an alkalotic state, but the opposite parameter is compensating that in a partial way to kind of bring the pH closer to normal. It's not quite normal, as you can see, it's still in the basic column, but without this compensation, if this CO2 was over here instead, then this pH would be even farther over here. Okay, so let's look at a different problem here, number 2. Let's go ahead and get rid of this. Okay, so we have a pH of 7.17. This is acid, so pH in the acid column. CO2 of 35, which is normal. It is in this range inclusively, so our CO2 is fine. Then we look at our HCO3, which is 12. This is too acidic, so we write down our HCO3, our bicarbonate, in this column. So where's our tic-tac-toe? It is right here, using the acid column. Acidosis, write down acidosis. Which parameter made up our tic-tac-toe? This is our HCO3, which is a metabolic parameter, so we are in metabolic acidosis. And where's the other parameter? It's over here. The CO2, this respiratory value, is in the normal column, so this means we are uncompensated. We are uncompensated because our primary condition is metabolic acidosis, and the opposite compensatory mechanism, in this case the respiratory system, is doing absolutely nothing to compensate for this disorder. That's why this value is still normal. If the CO2 was over here instead, then we would be in partially compensated metabolic acidosis, but since it's not, we are in uncompensated metabolic acidosis. And let's double check these first two answers. Let's bring this website back over here, click Show Answers, and I'm going to see if I can only show you these first couple at a time. Okay, so this first one was partially compensated respiratory alkalosis. Remember, that was our first problem. That was this one right here. And this new one that we just solved was uncompensated metabolic acidosis. This matches our problem. Okay, let's go to problem number 3 here. Let's get rid of this. Number 3. The pH is 7.45. This is normal, so pH goes in the normal column. Our CO2 is 48, which is outside of this range, it's more acidic. So we write down our CO2 in the acid column, and our bicarbonate is 28, which is also abnormal. It is basic though, so we write down our HCO3 in the basic column. Okay, so when this happens, when our pH is normal and our other two parameters are both abnormal, we know that we have a case of full compensation. So we can write down fully compensated. In this case, both of these are abnormal. One of them is going to be more abnormal than the other, and so we actually have to do an extra step here to figure out which one of these is being more abnormal. So in this case, we have to go back to our pH value in the problem, which is this case, it is 7.45. Now we have to ask ourselves which side of our pH scale is 7.45 closer to. Now I'm going to actually write this pH scale out here a little bit bigger so we can get a better idea of what's going on here. So 7.35 to 7.40, and then from 7.40 to 7.45. This is more acidic, this is more basic, and this is neutral. Well, it's not absolutely neutral, but in this case we're going to consider it neutral. So if the value is 7.4, then this will be a special condition that will be talked about a little bit later. So we need to look to see which side our pH is, which side of the 7.4 does it fall on. So in this case, 7.45 is greater than 7.4, and so this means we have an alkalotic condition. So we are in alkalosis with full compensation. Now that we know we're in alkalosis, we look in the base column, the alkalotic column, and see which parameter made it up. So in this case, it's our HCO3, our bicarbonate. Remember, bicarbonate is a metabolic parameter. So our final value here is fully compensated metabolic alkalosis. And we'll do a couple more of these to kind of clear this out. This is the ones that students usually have the most trouble with anyway. So let's go ahead and get rid of this stuff here and do a couple more. Okay, so number 4, our pH is 7.42. pH is 7.42. This is normal, so pH goes in the normal column. CO2 is 40. This is also normal, so we write down our CO2 in the normal column. And our bicarbonate, 23, is also normal, so it just kind of goes down here. In this case, since all of our values are normal, this ABG is normal. There's nothing wrong with it. This is a healthy, well, probably a healthy individual, at least as far as you can tell from their ABG reading. So let's go ahead and work on this next problem here. Number 5. pH is 7.63. It's basic. pH, okay. Our CO2 is 24. It's also basic. Or I'm sorry, our CO2 is 24, which is also basic. And our bicarbonate is acidic, so it goes over here in the acidic column. Okay, so let's go ahead and do our diagnosis now. So our tic-tac-toes here, we are in alkalosis. Our parameter that made it up is a respiratory parameter, so we are in respiratory alkalosis. Our other parameter is partially compensating because it's the opposite in the opposite column, so partially compensated. And I've been forgetting to double check these answers, but let's go ahead and double check here on the website again. So number 3, if we recall, it was fully compensated metabolic alkalosis. Number 4 was normal, and this is number 5. So number 5 should be partially compensated respiratory alkalosis. Partially compensated respiratory alkalosis. It matches the website, so this is a correct answer. Okay, let's go ahead and get rid of this and go on to problem number 6. Number 6. pH is 7.33. This is acidic, so this goes in this column. CO2 is 22. It's basic, so CO2 goes over here. HCO3 is 21. Acidic, it goes in the acid column. This is our tic-tac-toe, so it's acidosis, because that's in the acid column. Our parameter that made it up is metabolic. Our HCO3 is metabolic, so this is metabolic acidosis. And our opposite parameter is partially compensating, because it's in the opposite column. So let's go ahead and double check our answer here. This should say partially compensated metabolic acidosis. Partially compensated metabolic acidosis. So we are correct here again. Okay, let's move on to problem number 7. pH of 7.15, which is acidic, so pH goes over here in the acid column. Our CO2 is 46. It's also acidic, so CO2 goes in the acid column as well. And our HCO3 is 34, which is basic. So it goes in the basic column. Let's see how our tic-tac-toe was formed. Right here, the acid column, so we are in acidosis. It was used, or our tic-tac-toe was solved with our CO2 value. CO2 is a respiratory parameter, so we are in respiratory acidosis, and our opposite parameter is in the opposite column, so we are partially compensated. Let's go ahead and double check our answer here. This is problem number 7. So problem number 7, partially compensated respiratory acidosis. So we are correct here once again. Okay, let's go ahead and move on to problem number 8. Let's get rid of this. So number 8, 7.54 is our pH. This is more basic, so pH goes in the base column. Our CO2 is 24, which is also a base. And our bicarbonate is 25, which is, it's normal, it's in our range. So our HCO3 goes in the normal column. Our tic-tac-toe is over here in the basic column, so we are in alkalosis. The parameter used to make up the tic-tac-toe is CO2. CO2 is a respiratory value. And our opposite parameter is doing nothing. It's in the normal column. So it is uncompensating for our condition here. So let's go ahead and double check our answer. Uncompensated respiratory alkalosis. Uncompensated respiratory alkalosis. Okay, so this matches. Okay, moving on to problem number 9 here. Okay, so problem number 9. pH is 7.35. 7.35 is normal, so pH goes in the normal column. The CO2 is 42. 42 is normal. Okay, so we write down CO2 in the normal column. And our bicarbonate, 25, is also normal. So this is another case of this pH is fine. It's another normal ABG reading. Okay, moving on to problem number 10. Oh, actually, let's double check that really quick. So number 9 is normal. Normal. Okay. So number 10, pH of 7.55. This is basic. CO2 of 20. This is also basic. And an HCO3 of 19, which is acidic. So tic-tac-toes here, basic column, so alkalosis. Our parameter used to make it up is CO2. CO2 is a respiratory value, respiratory alkalosis, and our opposite parameter is partially compensating. So let's go ahead and double check our answer here. Partially compensated respiratory alkalosis. Okay, so this is correct. So this website is a really great resource to use if you need more practice. So you can hide or show the answers depending on what you want to see. If you need more practice, you simply refresh the page and you have 10 new problems and 10 new answers to solve. You need 10 more, refresh again, 10 new problems, 10 new answers.